Hi, in this video we are going to talk about the other shortest path algorithm, the so-called Bellman Ford algorithm. So let's get started. It was invented in 1958. It is slower than Dijkstra's algorithm, but much more robust. It can handle negative edge weights too. As you may recall, as far as Dijkstra's algorithm are concerned, it can handle only positive edge weights. With the help of Bellman Ford, we can handle negative edges too. So Dijkstra's algorithm chooses the edge greedily with the lowest cost, and we see that it is proved to be a good solution. But Bellman Ford relaxes all the edges at the same time for v-1 iterations, where v is the number of vertices in our graph. So we not keep going from vertex to vertex and keep the relaxation process. We keep relaxing all of the edges at the same time. So the running time is ordo v times e, where v denotes the number of vertices and e is the number of edges. So it is much slower, or not much slower, but it is a slower algorithm than Dijkstra's, but it is much more general. I mean, it's much more robust. It can handle negative edge weights. So it does v-1 iterations plus 1 to detect cycles. If cost decreases in the width iteration, then there is a negative cycle because all the paths are traversed up to the v-1 iteration. So if the cost decreases, we know that there must be a negative cycle. So the applications, we can use it in the RIP, Routing Information Protocol. This is a distributed algorithm. Each node calculates the distances between itself and all other nodes and stores this information as a table. It is a networking protocol and a networking algorithm, so that's why it's important. The second step, that each node sends its table to all adjacent nodes. And when a node receives distance tables from its neighbors, it calculates the shortest routes to all other nodes and updates its own table accordingly in order to reflect any changes. And another application of the Bellman Ford algorithm is concerning stock markets and forex markets. And we can calculate that, for example, we change some money from Hungarian forints to euro, then euro to dollar, then dollar back to Hungarian forints, and maybe there's an arbitrage situation. And these kinds of arbitrage situations can be detected with the help of Bellman Ford algorithm. And it's very important. Then there's the so-called yen optimization. It was invented in 1970. The yen algorithm, it is the Bellman Ford algorithm with some optimization. We can terminate the algorithm if there is no change in the distances between two iterations. So we make iterations and we watching whether there is a huge change in the cost or not. So we use the same techniques in bubble sort, by the way, it doesn't matter. But this optimization can be used in order to boost up Bellman Ford algorithm. And sometimes it's very important when, as I said earlier, for example, high frequency trading techniques relies heavily on a Bellman Ford algorithm, and it's very important to make it as fast as possible. And the yen optimization does the same. So that's how Bellman Ford algorithm works. Thanks for watching.